Profile control tolerances. Let us understand what is profile. It is actually an outline of a surface, a shape made up of one or more features, or a two-dimensional element of one or more features. Then what is true profile? The true profile defined by basic radii, basic angular dimensions, basic coordinate dimensions, basic dimension of size, undimensioned drawings, formulas, or mathematical data, including design models. These two will be useful while understanding what is that profile tolerance zone controls. It controls the profile relative to true profile. The profile tolerance zone, profile tolerances are used to define a tolerance zone that control form. You see what that form control tolerances did: straightness, flatness, circularity, centricity. That is what form. Or combinations of size, even the dimensions, form, again, orientation, angularity, perpendicularity, parallelism, and location of features related to a true profile. Depending on the design requirements, the profile tolerance zone may or may not be related to datums. It is related to datums when it comes to this form size control. When it comes to orientation and location, orientation may require datums, but location sometimes doesn't need datum reference at all. Even the form doesn't have any reference related to datum. And again, it specifies a uniform or non-uniform, even non-uniform transform boundary. If it is uniform, it is equally disposed from the true profile, either side, both side. Or if it is either side, either one of the sides, then it is non-uniform tolerance zone along the true profile. And understand that what is that? It is controlling the surface or single elements of the surface where it should lie. And what is profile tolerance? There are two types of profile tolerance, as you know. There is a profile of a surface and profile of a line. The profile of surface tolerance is a three-dimensional. It is like a volume extending along the length, width, the circumference, all over the circumference of the considered feature or features. And profile of line may be applied to any shape, including parts that have a varying cross section, a tapered wing of aircraft, a constant cross section as an extrusion. Whether it is desired to have a tolerance zone that includes entire surface of the feature as a single entity. Profile tolerance is general idea about the profile tolerance. Profile tolerance is most flexible control in dimensioning tolerancing system, as it controls everything that we are talking about that is hidden by the nature. For example, the form and location, orientation. These are all the very interesting things that not reveals out the true geometry behind it. Can be applied in place of dimension itself as a refinement of a size dimension. It may be related to datums when it comes to orientation, location, positions, and it can control any irregular shapes like cam surface, automotive sheet metal parts, that's BAW parts especially. And usually in BAW parts, it controls this trim profile, that is called outline of a shape, and it controls the three-dimensional aspects of the BAW parts by measuring the gap between the true profile, that is called a fixture, maybe inspection fixture, over which the part is placed, and then measured, the gap is measured all over. and line profile tolerance zone. This we should understand where we are going to have a control over the surface by using line profile. If you know the tolerance zone exactly, then you will be in a position to understand the stack up analysis problems very easily. Why we are putting half a tolerance in the right side and left side of the column, which is going to calculate the gap between the actual gap between the parts or the dimension that we are interested in assemblies. The tolerance zone for line profile is as in the first picture. It's a straight line parallel to two parallel straight lines about or along the true profile, and then concentric circles as in the third figure, and the profile, the line profile as a surface element, straightness, circularity. See, line profile, what it is controlling? Straightness, circularity. It controls straightness as in the first figure, and as in the third figure, circularity and orientation as in the middle figure, and then circular runout, in fact, of the same surface. And the surface profile. The surface profile tolerance zone is parallel planes above the true profile, and concentric circles, the complete concentric cylinders actually along the cylinder as a length, and offset surface profile across the true surface. And the surface profile can control the same surface as flatness, what the flatness control do and does, and cylindricity, circular and total runout also. Profile tolerance zone syntax. If you see any of these symbols in any drawing, it means that the first profile of a feature must be within 3000s, and line profile of a feature must be within 6/1000s relative to datum A. You see this symbol and relate it to the tolerance zone figure, and then you think that whether how it is going to be used, that this data, this information is used in the stack up problems. And this one means the surface profile a feature must be within 3/1000s relative to datum ADE between points L and H. You see that this is very special symbol here, and a lot of special symbols are there in profile tolerance zones. And the second symbol in the drawing means that surface profile of feature must be within 6/1000s relative to datum ADE and within 3/1000s relative to composite tolerance to datum feature A. And profile tolerance is profile tolerance is summary. This line profile and surface profile may or may not require datum reference. It can be all alone when it comes to form control. When it comes to orientation and other controls, it requires datum. And it controls surface, but it doesn't control feature of size. It controls only the features. And then whether we can use MMC LMC, no, it cannot be used with the MMC or LMC conditions, because it's a size doesn't control the feature of size. Can use tangent modifiers? Yes, we can use tangent modifiers. Thank you for watching this video.